So in the first part of this question, I'm asked to simplify m to the 3 multiplied by m to the 4 here. So initially here, I've noticed that we're working with indices. We're working with two lots of m raised to different powers, and we're going to be multiplying them together. So if I'm thinking back to my laws of indices, and we're multiplying two different values together, I'm instantly thinking here of an example such as x to the a multiplied by x to the b. Now what we do here is we take the powers and we can add them together. So this would leave a result of x to the a plus b. Now this is a law of indices, so when we have two lots of m to different powers, we can simply add the powers together. So in this case we have, following the same principle, m to the power of 3 plus 4 gives us an answer of m to the power of 7, which I can put in here, as that's a fully simplified answer to this question. So now in this part of the question, we're asked to simplify this expression here. So 5 lots of np cubed, and then that whole bracket is going to be cubed. And we need to look at how we're going to simplify this. So in effect, this bracket that we have here is the same as writing out 5 multiplied by n multiplied by p cubed, and then that whole thing's going to be cubed. Sometimes it helps to look at it that way, just so we make sure that we know that we're not adding or subtracting any terms like this. So to cube this bracket, I basically have to cube each of the individual terms. So I'm going to raise each term to the power of 3. So if I start with the 5 here, I can raise the 5 to the power of 3. So 5 to the power of 3, and that's going to be multiplied by this n in the bracket raised to the power of 3. So multiplied by n to the power of 3, multiplied by, finally, p to the power of 3 to the power of 3 again. So p to the power of 3 to the power of 3. Now, similarly to the previous part of the question, I've got p to the power of 3. I'm raising it to the power of 3. This is going to require some knowledge of indices laws again. So if we have x to the power of a, and we're raising that to the power of b, this is going to give us an answer of x raised to the power of ab. So a multiplied by b is going to give us the power here. So in this case, when we have p to the 3 to the 3, we're going to do p to the power of 3 multiplied by 3 gives us p to the power of 9. So we have 5 to the power of 3 multiplied by n cubed multiplied by p to the power of 9. And we can rewrite that, so we have 5 cubed gives us 125. N cubed is as simplified as it can get. We can just write n cubed down. And then we finally have p to the power of 9. And these are all going to be multiplied together, so we can just write them together as one expression as 125 n cubed p to the power of 9. And that gains us both of the marks here. So the first mark would have been for 2 of the correct terms in this product, and then the second mark is for this fully correct answer. And then finally here, we're asked to simplify 32 lots of q to the 9 r to the 4, and that's all going to be over 4 lots of q cubed r. So we're working with a bit more of a complex expression here that we're looking to simplify. We have a quotient, so we have a fraction, so there's going to be some kind of division involved here. And just to make it a bit easier for us, I'm going to start by writing this fraction out in a bit of a nicer form. So the terms in the numerator and denominator, they're all multiplied together. So we have 32 multiplied by q to the 9 multiplied by r to the 4 here. So that's going to be useful to work with. I could rewrite this fraction. I could write it as 32 multiplied by q to the 9 multiplied by r to the 4 all over 4 multiplied by q to the 3r, so times r. And then, because we're multiplying all of the numerators and the denominators, the terms in each of those, we can simplify this again just so it's a bit easier to work with. So if I separate the numbers, so the integers here, we can take 32 over 4, and we can leave that as its own fraction. we can multiply this fraction by q to the 9 over q to the 3 to keep the q terms together, and then multiply that fraction by r to the 4 over r. Now this shows how we're going to work with the fraction. We didn't have to write it out like this to understand what we're going to do with the terms, but it is useful to kind of see how it looks and how we're working with it. So now I can simply take all of these fractions, simplify them and multiply them back together. And I can start with 32 over 4, that just gives me an answer of 8. And then we're multiplying that by q to the 9 over q to the 3. So here, again, I'm going to be referring back to my laws of indices. So for example, if I had x to the a over x to the b, so when we have the same sort of variable raised to two different powers, one over the other, this gives us an answer of x to the a minus b. So to find the new power, we subtract the denominator power from the numerator power. So here, working with the q's again, I can take q to the power of 9 minus 3 here. And then I need to multiply that by r to the power of, by the same principle, 4 minus 1. So we now have 8 multiplied by q to the power of 6 multiplied by r cubed. And because we're multiplying these together, we can just write them out next to each other. So the final answer here is 8q to the 6 r cubed. And we would get 1 mark for getting 2 of these terms right, and then the second mark for having the fully correct answer that we have here. So here I'm asked to find the lowest common multiple of both 40 and 56. Now, when I see the phrase lowest common multiple, I'm instantly thinking about using the prime factors of these numbers and how I can use these factors in order to find this lowest common multiple is kind of a skill that is taught and worked on at GCSE. I could simply list out a few multiples of both 40 and 56 and find the lowest one. However, this method makes sure that we've not missed any or done any of the calculations wrong, and we don't have to spend the time listing out these multiples. So if I take firstly the prime factors of each of the two numbers, so 40, I can split this into 2, which is prime, and 20, and again divisible by 2, and 10, and then 2 and 5 this time, and 5 is also prime. So those are my prime, that's the prime factorisation of 40. And I can do the same for 56. So again, I'll just start with 2 because it's easy to work with, and 56 divided by 2 is 28. Divide that by 2 again because it's even, gives me 14, and I can divide 14 by 2 and that will give me 7, and 7's also prime. So we have found the prime factors of 56 as well. Now to find the lowest common multiple of these, I'm going to put them into a Venn diagram. So if I take a Venn diagram and I have my two circles, and I'll label this one 40 and this one 56. Now I can put my prime factors in here. So as you can see, we've got 3 2's that are the prime factors of 40, and also 3 2's for 56. So these can go in the intersection of the Venn diagram, the points where they cross. I can put in the 3 2's. Similarly, I can now take the other factors, so 40 has a factor of 5 that hasn't been counted, however 56 does not, so that just goes in the region that's just the 40, and then similarly the 7 can go in here. So now to find the lowest common multiple from this, I can use these prime factors, taking into account the shared prime factors here, so the 3 2's, and multiply them all together to find the lowest common multiple. So we have 2 multiplied by 2 multiplied by 2 multiplied by 5 multiplied by 7, and this is going to give me the lowest common multiple because it's taken all of the prime factors into account but taken out any duplicates, so we've gotten rid of any of the prime factors that we've been sharing here. So this gives me an answer here, if we multiply these together, of 280. And we would have gotten the same answer if we'd have listed the multiples. However, it would have taken a little while to get to 280 when looking at multiples of 40 and 56. So we'd gain the first mark here for finding the prime factors of both numbers, or for listing at least 3 of the multiples, and then the second mark is for getting the correct final answer here. I'm now asked to write down the highest common factor of A and B, which we have above. Now this is similar to the previous part of the question, in the sense that I'm going to go with a kind of Venn diagram approach to this again. So looking for the highest common factor instead of the lowest common multiple this time, if I were to draw out a Venn diagram of A and B and their prime factorisation, the highest common factor is going to be whatever's in the intersection, so this region of the Venn diagram, multiplied together. And that's going to take the common prime factors, multiply them together to gain the highest common factor of both A and B. So in this sense, I could draw out the Venn diagram, or I could just look at which prime factors A and B have in common. So A has 2 to the power of 3, so that's basically the same as taking 2 multiplied by 2 multiplied by 2, multiplied by 3 multiplied by 5 is the prime factorisation of A. Similarly for B, we have 2 squared, so 2 multiplied by 2, that's multiplied by 3, multiplied by 5 squared, so 5 multiplied by 5. Now I just need to look between A and B and find these factors that are in common. So if we take 1, 2 from each one, and then we can also take another 2 from each one here, we can take the 3, that's common, and then we can take 1, 5. So there's lots of common factors here. However, we have this multiplied by 2 in A and the 5 in B, which aren't common, so we can just work with the ones that we've circled. So then the highest common factor is going to be 2 multiplied by 2 multiplied by 3 multiplied by 5. Here, multiplying the common factors together, and that gives us an answer of 60. And that is going to be the correct answer here to gain us the mark. So here we have the line L, which is shown on the grid, and we're asked to find an equation for this line L. So if I have a look at the grid, we have the x-axis here and the y-axis, and this is the line L, which is a diagonal straight line here. So if we're looking to find its equation, I always find it useful to basically write down the general form for an equation of a straight line, just so I can see clearly what I'm working with. So that is going to be y is equal to mx plus c. This is a general equation for a straight line. And if I have a look at this, basically we substitute in a value of x to obtain a value of y here. And we have m and c, which are fixed constants. So m in this case is going to be the gradient of this straight line graph. That's what this constant is going to be. And we can just substitute m in as whatever we calculate the gradient to be, and then we have this value. And then c here is going to be another constant, but this constant is going to be equal to the y-intercept of the graph. Now we can see this because when we have the y-intercept, the x value is going to be 0 when we're working with the y-axis. So this value here is going to be 0. If x is 0, mx is also 0. So y is equal to c. So the y-intercept is going to be this value of c. So I can then use this information to calculate and work out the equation of the graph. So if I start by working out the gradient, so m, we calculate the gradient by finding the change in y, so delta y, over the change in x for this straight line graph. Now I can do this by drawing out a triangle like so. So it can be any size, just going between 2 points on the line, and it's a right angled triangle like this. So now I can look for the change of y and the change in x. So if we start with x, we start with x is 0, and I'm going up here along this bottom line of the triangle, the horizontal line, to where x equals 2. So this is a change in x of 2, so 2 squares. And similarly for y, we start at -6, and we're going to go up 6 squares to 0, so there's a change of 6 squares. And then I can write this out, so the change in y is 6 over the change in x, which is 2, and that gives me an answer of 3 for the gradient. So if I substitute this back into the equation, we have y is equal to 3x plus some value of c. Now there's a couple of different ways we could work with this. We could substitute in a value of x and y that's on the line, so a coordinate, and we could work out the c by just rearranging that. Or we can simply look at the graph and find the y-intercept, so the c value here. So the y-intercept is when x is equal to 0 on this line here on the y-axis, where that meets the line L, which is here at -6. So c is going to be equal to -6. And then we can simply substitute that in to get our final answer. So y is equal to 3x, and we need to make sure we have this negative sign, -6. And that brings us to the correct final answer for the equation for this line. Now as for how the marks are awarded here, we would get the first mark for basically working out this gradient that we did of 3. And then another mark for writing down this equation here. So just stating that we know that y is equal to 3x plus this value of c that we're then going to work out. And then the final mark was for this correct final answer here. There are a couple of different ways you can go about getting the marks. It just depends which order you've calculated things in and how you've used these values, and maybe substituted in values to find c, or maybe you just read it off as the y-intercept. So here I'm told that Rhea buys a van for £8,500 plus VAT at 20%. I'm then told that Rhea pays a deposit for the van, and then she pays the rest of the cost in 12 equal payments of £531.25 each month. And we're asked to use all of this information to find the ratio of the deposit that Rhea pays to the total of the 12 equal payments. And we're asked to give the answer in its simplest form. So it's a lot of information to take in here, but if I go back to the start of the question, we're told that she buys a van for £8,500 plus this VAT at 20%. Now if we're working with the total cost of the van, it's going to be a good place to start to work out this total cost, including the VAT. So if I go to work out this total cost of the van, I need to find what £8,500 is plus this 20% VAT. Now, if I have an extra 20% on top of this, I can take the multiplier of 1.2 to multiply this by 8,500 in order to work out what 8,500 is plus 20% of it. So 20% as a multiplier would be 0.2, but I'm multiplying it by 1.2 to have that original 8,500 included. So using this multiplier of 1.2, so increasing the value by 20%, I get an answer here of £10,200 for the van. So Rhea then pays a deposit for the van, but then she pays the rest of the cost in 12 equal payments. So we're not told the deposit here. However, we are told that there are 12 equal payments of £531.25 each month. So we can work out the total amount she's paid via these payments. So if we work out the total cost of her payments, well, if she is paying £531.25 every month for 12 months, so 12 equal payments, we can multiply that by 12 in order to work out how much she's paid. And that gives us an answer of 6,375. So that was the rest of the cost that she paid after paying the deposit. However, we don't know the deposit and we're looking to calculate the deposit. So in order to calculate the deposit that she put down to buy the van, we can take this total cost of the van and subtract the monthly payments in order to find the difference and to find the amount that she must have paid for the deposit, because the deposit plus the total number of payments, the total cost of these payments, is equal to the total cost of the van. So I can do the 10,200 subtract 6,375, and that gives me an answer of £3,825 for the deposit for this van. Now here, if I look, I'm asked to find the ratio of the deposit that she made to the total of the 12 equal payments, and we have both of these values here. So we're basically finding a ratio of the deposit to the 12 payments, and the deposit was 3,825, and we're going to put that in a ratio with the total cost of the payment, so this part of working here, so to the 6,375. And that gives us a ratio. This gives us the final ratio that we're working with. However, here we are asked to give our answer in its simplest form, so we're going to have to divide down this ratio. So these numbers are going to share a common factor, and one way of working out this is if I were to divide both of the sides of the ratio here by the same amount. If I were to divide them both by 3,825, for example, I'd get 3,825 divided by itself, so 1, and then I'd get 6,375 divided by 3,825, and that gives me an answer of 5/3. Now with ratios, it's better to work with whole number ratios, so I can simply multiply both sides of this ratio by 3, and that gives me a ratio simplified in its simplest whole number form of 3/5, and that will be the correct final answer here. So as for how the marks are awarded for this question, the first one would be for finding this total cost of the van, the second for finding the total cost of the payments, the third for finding the deposit, the fourth would then be for finding an unsimplified ratio, and then the fifth and final mark is for finding the simplified ratio of 3/5, or the answer 1/5/3 would have been accepted, but it's always a good idea to give them as whole numbers. So the way that we've laid this question out, giving a little more detail on what we're doing each stage of the working, writing down what we're calculating, has been really helpful in showing where we got all of the marks here and how it came together to give us this full answer of 3/5. So for the first part of this question, we're asked to complete the table of values for y is equal to x squared minus x minus 6. And if I have a look at the table, in the first row, so we have this row here, which is the row of x values, and these x values range from -3 up to +3. And then the second row of the table, we have y values. So we have some filled in, a couple filled in, then we're also missing some y values, so this is what we're going to be looking to calculate. So if I refer back to the equation we have here, in order to find a y value, we're going to take the corresponding x value, so the x value in the same column, so for example, this x value is linked to this y value here, and we can substitute it into this equation, which is a quadratic equation. So we would substitute in the values of x, so we would square the value, would minus the value of x, and then would minus 6, and that would give us an answer for y. So if I do an example of this, so if we take when x is equal to -2, for example, if y is equal to x squared minus x minus 6, and we're looking to calculate y, we square x, so -2 all squared, subtract another x, and then subtract 6, and that gives us an answer of 4 minus -2, so +2 minus 6, which gives us an answer here of 0. So I can fill that in to the corresponding y column that's linked to when x is -2. Similarly, I can do the same for -1. So -1 squared is 1, minus -1 is 1 plus 1, so 2. 2 minus 6 gives us an answer of -4 here. So I can fill that in also. We can move on here to when x is 1. 1 squared is 1, subtract 1 is 0, subtract 6 is -6. For 2, we have 2 squared, which is 4, subtract 2 gives us 2, subtract 6 gives us -4. And then finally, we have 3 squared, so 9, subtract 3 gives us 6, subtract 6 gives us 0. And we can kind of see a pattern emerging here as well. If we go from 0 to -4 to -6, and then back to -6 to -4 to 0. And we'd expect that kind of thing to happen somewhere in this graph because we are working with a quadratic, so a curve here. We're then asked to draw on the grid the graph of y equals x squared minus x minus 6 for values of x from -3 to 3. And then I have here the table that we've just worked out with the new values of y that we've put in. So effectively here, when we have the values of x and y, we've basically just formulated some coordinates that are points on this graph. So for example, if we have coordinates x, y, then points on this graph are going to include -3, 6, and then -2, 0, -1, -4, 0, -6, and so on. So we can just go through and plot these points on the graph, and then we can draw a line, a smooth curve through all of these points. Now we know what we're expecting from this graph. We have an x squared term, so we're expecting a quadratic, and it's a positive, it has a positive coefficient, so a coefficient of 1 here means that it's going to be a kind of upwards curve, a smiley face, instead of a negative one, which would be more of an N shape or a frown. We can also see that it's going to have a y-intercept of -6 here, so that's also something to look out for, and it's going to be a smooth curve because it's a quadratic. So we can just be checking for all of these things to check we're plotting our points correctly. So firstly here, if I start by plotting the first point, so -3, 6, I can plot that on the graph like so. Then -2, 0 is going to be at this point here, so I'm going to -2 on the x-axis, and then I'm going to 0 on the y-axis, which is just this point already. Similarly, -1, -4, so I take to -1 on the x-axis and then -4 on the y-axis to get the point here. We then have 0, -6, 1, -6 again, 2, -4, and 3, 0. Now I can see a curve emerging already, and now I just need to draw a smooth line through all of these points. I also need to make sure that this line is going to go below these 2 points here. As these are at the same height, there must be a turning point below them, so there must be a smooth curve between these two that goes below them. So now I can just draw this smooth curve in carefully. Just ensuring that I do go through all of the points there. Now, for how the marks are awarded here, you get the first mark for plotting at least 5 of these points correctly, and then the second mark is for a fully correct final graph here. finally here, we're asked to use the graph to find estimates of the solutions to the equation, which is x squared minus x minus 6 is equal to minus 2. So if we're working with this graph of y equals x squared minus x minus 6, however, we're having this to be equal to minus 2, then we're going to be looking for the values on the graph where y is equal to minus 2. So this minus 2 is kind of in the place of where the y was. So if we're looking for where y is equal to minus 2, and we find the x values corresponding to the graph at these points, then we're going to have found the estimates of the solutions to the equation. So two x values here that are where the line y equals minus 2 cross the line y equals x squared minus x minus 6. So in order to go about doing this, I can simply draw in the line of y equals minus 2. So this straight horizontal line here, and label that y is equal to minus 2. Now if we look at where it intersects the curve, we have a point here and a point here. So it intersects the curve twice. And we would kind of expect that because it's said to find the estimates of the solutions, plural, and we're working with a quadratic here. So now I can look at these values and I'm trying to find the x values corresponding to these points. So if I trace up from these points up to the x-axis here, we can see we have one at minus 1.6, and similarly this point is at 2.6. So then my final answers here are minus 1.6 and 2.6, which are the solutions to this equation that we are given. Now, as for how the marks are awarded, you would get the first mark for drawing in this line of y is equal to minus 2. And then the second mark would be for getting the correct answers here, which can be in the range of minus 1.5 to minus 1.7, so 0.1 either side of the answers that I've given here. So here we're told that a force of 70 newtons acts on an area of 20 centimetres squared. We're told that the force is increased by 10 newtons, and then the area is also increased, and that's by 10 centimetres squared. We're told that Helen says that the pressure decreases by less than 20%, and we're asked whether Helen is correct, and told that we must show how we get to our answer. So the question is worth 3 marks, so it's going to take a bit of working before we can come to a conclusion on this question. We're also given the formula for pressure, so pressure is force divided by area, and we're going to need to work with that in this question. So if we're working out a way of looking at how the two pressures relate, whether it decreases by more or less than 20%, we need to work out the initial and the new pressure. So if I start by working out the initial pressure, so if pressure is equal to force divided by area, then we have the initial force, which is 70 newtons, and the initial area, which is 20 centimetres squared, and that gives us an answer of 3.5 newtons per centimetre squared, but because the units here are going to be the same, because we have centimetres squared in newtons and newtons in centimetres squared, just because we're doing this comparison, we don't really need to work with the units in this sense, because they're both going to be the same. So there we've worked out the initial pressure, and now we can work out the new pressure using the same sort of method. So if the force increased by 10, we have 70 plus 10 for the force here, and we're dividing that by the area, which is 20 plus the 10 as well. So here we have 80 over 30, and that gives us an answer of 2.6 reoccurring. So now we've got our two pressures, we need to look at a way of comparing them. So if we're looking to test whether the pressure is decreased by more or less than 20%, we could take the initial pressure and see where a 20% decrease would take us to. So if I take the 3.5 and I want to see what 20% less than that is, I can multiply it by 0.8, so find 80%, which is 100% minus that 20% of 3.5, and that gives me an answer of 2.8. So a 20% decrease from the 3.5 gives me an answer of 2.8. However, the new pressure is 2.6 reoccurring, or rounded to 2.7, and 2.8 is greater than 2.6 reoccurring. So we can conclude with this information that Helen is going to be incorrect because the pressure has decreased by more than this 20%, because 2.6 recurring is lower, it's further away, it's much less than 3.5 than that 2.8% is. So no, Helen is incorrect. The decrease is more than, as opposed to less than, 20%. And that is the correct conclusion here for this question. As for how the marks are awarded, the first mark is for calculating the initial pressure or the new pressure, one or the other. And then the second mark is going to be for a more complete process to make this comparison. So this step here, multiplying it by 0.8 to find 80%. And then the final mark is for this correct conclusion, so working with these two values here, and then coming to this correct conclusion gains us the third mark, as long as we've supported the conclusion with these values. There are a couple of different ways you could go about this question. You could work it out by working with the new pressure. There's lots of different ways. You could work out the percentage change and see whether this is more or less than 20%, but any way should bring you to the same conclusion that we've gotten to here. So in this question, I'm asked to enlarge shape A by the scale factor of a third, and this has a centre of 0, 1. So when I'm working with transformations, it's a good idea to make sense of the shape that I'm working with to begin with, and to have a rough idea of what's going to happen to it. So if we have a look at the centre 0, 1, that's going to be this point here, which is already marked on the graph, and then we have this shape A here. Now we're enlarging this shape by a scale factor of a third, and a third is less than 1. So in a sense here, we're going to be shrinking the size of the shape. The shape is going to end up smaller than it was originally because the scale factor is less than 1. So we're going to be looking for a smaller shape. We're also going to be looking for a shape in the same sort of orientation. So it's going to look like shape A, it's going to just be a bit smaller and in a different place. So it's not, because there's not a negative scale factor, it's not going to be in another quadrant, it's not going to be flipped, it's going to be the upright image, just a third of the size in a sense. So now I can start working with the image now that I've got a good idea of what it's going to look like, and I can perform this enlargement on shape A. So a good way to do it is work from the centre of 0, 1 and then draw lines out to the points on shape A. For example, if I start with this top left point. Now if we want to enlarge it by a scale factor of a third, we basically need to find a third of the length of this line, and then we can mark on the same point on A on this new shape that we're drawing. So for this line that I've just drawn in here, we've basically gone 3 across on the x-axis, so an increase of 3 on the x-axis, and then 9 upwards in the y-axis. So if we've had a kind of movement of 3, 9, if we were to write that in coordinate form, and we want to enlarge this shape by a scale factor of a third, we can kind of multiply this by a third to find the new point of the new coordinate of this point. So if I were to multiply that by a third, we could then move 1 across and 3 up to get to our new point here. So if I take 1 across and 3 up, we're going to get to the point 1, 4, which I can mark on the axes here. So similarly for the other points, if I draw the line out, then I can see here that we need a third of the length of this line because that's the scale factor. And we've moved across here by 6 and up by 9 again. So if we multiply this by a third, we have 6 multiplied by a third, which gives us 2 across, so 2 in the x-axis, and then 9 multiplied by a third gives us 3 up in the y-axis. So we reach this point here, which again seems right because we have these 2 points which have the same y value here, and then we're going to have that side here, which is going to be a third of this because we have 3 squares here and just 1 here. So working with this same sort of idea, if I want to look at this point, now we have 6 squares, this side is 6 squares long, and if we multiply that by a third, because of this scale factor, we're going to get 6 multiplied by a third, which gives us 2. So I now know that the side here is going to be 2 squares long. So I didn't even have to draw the line on this one. I can simply mark the point here 2 squares lower than this point here. So a decrease of 2 in the y-axis at this point. And then we can just about see where the next point and the final point is going to be. But similarly here, if we take the 3 squares that we have here, so between this top right corner and this final point we need to plot, we've got 3 squares in the y-axis. I can multiply this by a third to give me 1, and I can take this point here, which is the top right point on A, and move this down by 1 to get this point here, which we can see does basically make up the shape A if we are to connect all of these points together to get our new shape, which is a third of the size of shape A. It is the same orientation and looks the same, it's just smaller than A. And that's how we enlarge this shape by a scale factor of a third with the centre that we're given. So here we'd gain the first mark for either a diagram of the correct size and orientation but in the wrong position, or for having 3 of the 4 vertices correct and joined together, or for having 4 correct vertices but not joining them together to make the shape. And then the second mark here is for this fully correct enlargement with the coordinates that I've shown in the diagram. So in this question, I'm told that 60 people were asked if they prefer to go on holiday in Britain or in Spain or in Italy. And then I'm given some more information about these numbers of people. So we're told that 38 of the people were male, 11 of the 32 people who said Britain were female, 8 males said Italy, and 12 people in total said Spain. And then we're told that one of the females is chosen at random, and we're asked to work out the probability that this female said Spain. So we're given quite a lot of information here, lots of numbers and probabilities to work with, and in this case I'd often find it useful to create a sort of table here to fill in my values and see what I'm missing and what I can work out. So if I take that the options here are male and female, I can create rows in a table. So we can have 2 rows for both male and female, so M for male, F for female, and then this is going to be a total row. And then similarly for the columns here, I can take the 3 countries I have and create rows for each of those. So I'll have these countries as the columns, so B for Britain, S for Spain, and I for Italy, and again we need a total row here. Now I can just start by filling in some of the information that I'm given. So I'm told that 60 people in total were asked. and that needs to be the total of everyone in the entire table is going to sum to 60, and that's going to be this box here. So this point here is going to be that 60. We're then told that 38 of the people were male, so the total number of males was 38, so that can go in this box. So we have the male row, and then the total column gives us 38. We're then told that 11 of the 32 people who said Britain were female. So from this, I can gather that 32 people said Britain and 11 of them were female. So the total number of people that said Britain, so the Britain and the total gives us this box here, is that 32. And 11 of them were female. So those that were female and chose Britain were 11. So I can fill that in here. I'm told that 8 males said Italy, so I can fill that one in. And I'm told that 12 people in total said Spain, so I can fill 12 in here. Now, if I'm trying to work out the probability of a female saying Spain, I need to work out this box here. However, I don't have enough information to do that initially, so I can just start by working out some of the other boxes which will help me get to this final answer. So, for example, I can take this bottom total column here. So the totals for the 3 Britain, Spain and Italy columns need to sum to this 60 here. So I can take that and take 60 minus 32 minus 12 to get the total for Italy. And that gives me an answer of 16. So I can fill that in the table here. I can now use this to fill in the Italy column. So this box here is going, these two boxes, the male and female for Italy, have to sum to this 16 total for Italy. So I can take 16 and subtract 8, the 8 males, to leave me with 8 females who also chose Italy. And then similarly here, the totals column here, then these two, the total number of males and females, need to sum to 60. So I can do 60 minus 38 to get me an answer of 22. So there are 22 females in total. And then I have this row here, so the female row. The females that chose Britain, Spain and Italy need to sum to this 22. So to find this, I can take the 22, subtract the 11 and the 8 to give me an answer of 3. So I can then fill the 3 into this box here. Now I have to be careful here because I'm told that one of the females is chosen at random. So my probability here is going to be out of the total number of females because we already know that a female is chosen. And we're asked what the probability that this specific female that's already been chosen, it is definitely a female, has said Spain. So the females that said Spain are this box here, the 3 that we've just calculated. And that's going to be out of the total number of females, which is this box here, and that's 22. So the final answer here is 3 over 22 for this probability. Now, as for how the marks are awarded, we'd get the first mark for finding a first value, so one of these values here, filling a box in, and another for finding a second, and then for a complete process to find how many females, the probability of a female saying Spain, we can take by taking this table and using the boxes that we've previously filled in with the 3 and the 22. And then the final mark is for the correct final answer of 3 over 22 here. So here I'm told that Jean invests £12,000 in an account paying compound interest for 2 years. We're told that in the first year the rate of interest is at X%, and at the end of the first year the value of Jean's investment has gone up to £12,336. We're then told that in the second year the rate of interest has changed and it is now X over 2%. And we're asked what the value of Jean's investment is at the end of the 2 years. So I know I'm working with compound interest, and initially that's making me think that I'm going to be working with some kind of decimal multiplier here. And if we're told that the rate of interest in the first year is this X%, I can rewrite this as a kind of decimal multiplier that gives me a value of X%. So if it's been an increase of X%, we can see that the number has gone up from the first year to the second year. We need to take the value of 1, so 100% of this first value. And then we need to add on X%, so X over 100. And that's going to give me a decimal multiplier, which takes us from the first value in the first year to the value at the start of the second year. So I can use this to set up an equation. We have this original 12,000, and we need to multiply this by something, which in this case is the multiplier, 1 plus x over 100. And then that gives us this second value here of 12,336. Now I can just solve this equation to find x, so I can divide both sides by 12,000 to give me 1 plus x over 100 is equal to 12,336 divided by 12,000, and then that gives me an answer of 1.028 to just a few decimal places there. I can subtract 1 from both sides to give me 0.028, and then I can multiply both sides by 100, and that gives me an answer of x being equal to 2.8 here. So we've solved this to find the value of x, which is the rate of interest. Now to go on and find the end value at the end of this 2 years, we need to work with the rate of interest in the second year. So we have this x over 2%. We have x, so now if I'm going to find x over 2, that gives me an answer of 2.8 over 2, so that's an answer of 1.4% increase on the value at the start of these 2 years. Because we're working with compound interest, this 1.4% interest is going to be on the value at the end of the first year. So I can take this 12,336, and now I need to have a percentage increase of 1.4%. So I need to multiply that by 1.014, that percentage multiplier here, decimal multiplier. So we have this 1.4% and this 1, this initial value, because we've got this increase. And this is going to give me a final answer for the value of the investment at the end of the 2 years, and that is going to come out as £12,508.70 here as my final answer, and that is going to gain me the marks for this question. So as for how each of them were awarded, the first mark is for starting a process to find this rate of interest for year 1, so setting up this equation here would gain that mark. A second mark is for a complete process to find the value of x, so the rate of interest, getting to this value of 2.8. And a third mark is for finding the value at the end of the 2 years. So this step, these 2 steps here, taking us to the final answer. And then the final correct answer here is going to be given, the mark's going to be given for the final correct answer that we have here, but it could be in the range of £12,508.70 to 71p. So we've got that 1p range, or depending on how we rounded our values throughout the question, the answer of £12,509 could come from the correct working if we've just rounded this a little bit differently. So here we have the vector A and the vector B, which are shown on the grid, and we have the grid here, so we have a kind of graph set up with the x-axis here and the y-axis here, and then we have the 2 vectors, so this vector A going in this direction and then the vector B going in this direction here. And we're asked to, on the grid, draw and label the vector of -2a. So firstly here, I know that I'm going to be working with the vector A, and I'm going to be working with -2 lots of this vector. So if I have a look at vector A here, now if I want to work out how to work with vector A, it's going to be useful to write vector A in some kind of numerical form so that I can represent it here and multiply it by this magnitude of -2. So if I have a look in the x-axis, from this point to this point, there has been an increase in 1 in the x-axis, so this increase in here from 3 to 4. So if I write this as a column vector, I can take this x value as an increase of 1. And similarly, in the y-axis, we've gone from this point here to this point here, so there's been an increase in 2 squares in the y-axis. So 1, 2 is this vector A as a column vector. Now to find a -2a, which is what I need to draw on this grid, I simply need to multiply the vector A by -2, and I can just multiply both the top and the bottom of this column vector by -2 because -2 is just a numerical value here that I'm scaling this vector by. So -2 multiplied by 1 is -2, and -2 multiplied by 2 is -4. So now I have the vector of -2a, and I can draw this anywhere on the grid here because this is a vector, it's just showing direction and magnitude, it's not from a certain place. So for example, I could start at this point here, and I now need to go 2 along in the x-axis, -2 back from this point, and then -4, so 4 down to this point here. So I can just connect these 2 dots up with this line, and I need to make sure I label the vector, so I'm just going to draw the arrow of the direction because we're going -2, -4, it's going to be downwards, and I can label this as the vector -2a here to gain me the mark. So here we're asked to work out a plus 2b as a column vector. So when I'm working with adding together these vectors to create a plus 2b as a column vector, well, I could simply work out what a and b are as column vectors themselves, and then I can just add 1 lot of a and 2 lots of b together in order to get this value of a plus 2b as a column vector. So similarly to the previous part of the question, if I want to find the column vector of A, which I did do before, column vector of A is going to be, well, to get from this point to this point, we see we go an increase of 1 in the x-axis and then this increase of 2 in the y-axis. So that's a column vector of 1, 2, so xy is 1, 2. And then for B, I can do the same thing. So to go from this point here down this vector to this point, there's been an increase in 1 in the x-axis, and then there's been a decrease of 3 squares in the y-axis. So B as a column vector is 1 minus 3. Now I can use these values to work out a plus 2b as a column vector. So I can just take the value of A, which is 1, 2, and now I need to add on 2 lots of B, which is 1 minus 3. Now, because I'm just working with a number multiplied by a column vector with this B part here, you can simply multiply both the top and bottom of this vector by this 2 in order to work out this value. So in effect here, I have 1, 2 plus 2 lots of 1, which is 2, add 2 lots of minus 3, which is minus 6. And then working with adding column vectors, I can simply add these x values at the top and the y values at the bottom to get this answer. So I have 1 plus 2 gives me 3 at the top, 2 plus minus 6 is 2 minus 6, so that gives me minus 4. And that is going to be the correct answer here for the column vector of a plus 2b. So as for how both of the marks are awarded, the first mark would be for kind of writing out this attempt to add this a plus 2 lots of b, And then the second mark would be for this correct final answer here of 3 minus 4 as the column vector. So here we're told that functions f and g are such that f of x is equal to 2 over x squared and g of x is equal to 4 lots of x cubed. And we're asked here to find f of minus 5. So I can see here that we're working with this function of f, so f of x is equal to 2 over x squared, and the function f of minus 5 basically is asking us to substitute minus 5 in as x in this equation. So here I can take if f of minus 5 here is going to be equal to 2 over x squared, and minus 5 is x, we can square this minus 5 to get us an answer of 2 over minus 5 squared, which is 25. And that is going to be the answer to this question. So I can just write that down here. The answer is 2 over 25. So we've just substituted in this value of minus 5 into the function of f of x, and that's given us this correct final answer here. So similarly, in this part of the question, we're asked to work with the same sort of ideas. However, this time I'm asked to find f of g of 1. And this is going to be slightly different because this time we're working with what's called a composite function. So this is where two functions are combined into a single function. So we, in this case, have f of g of x. And how we interpret this is that we're going to do whatever is closest to the brackets first and then what's further away. So this basically means we're going to do g first and then do f. So we're going to find g of x and then we're going to take this and do f of whatever the answer to that is. So I could just rewrite this here as f of g of x, and then we can do g of x first and then find f of that. So if I basically start by finding g of 1, again the same principle, I can substitute 1 into this g of x formula that we have here. So 4 multiplied by x, which is 1 to the power of 3, gives us an answer of 4. And now I need to find the f of that, so f of 4 is going to give us an answer of 2 over x, which is 4. So 4 squared, 2 over 4 squared is 2 over 16, and we can simplify that because they share a common factor of 2. The numerator and the denominator share this factor, they're both even. So we can divide them both by 2 to get an answer of 1 over 8 here to gain this final mark for this question. Now, the first mark here was awarded for finding the first part, so the g of 1 to give us 4, and then the second mark is for this final correct answer here of 1 over 8. So in this question, I'm told that the graphs of y against x represent 4 different types of proportionality, and I'm asked to match each type of proportionality in the table to the correct graph. So if I have a look at the table here, in this column I have the types of proportionality, and this symbol here simply means is proportional to. And then I need to fill in this column of the table with the letters corresponding to the graphs above. So if I just take a moment to make sense of the graphs that we've got to start with, we've got graph A, which is kind of a decreasing curve here, a smooth curve, but it's decreasing, the gradient's decreasing. For graph B, we have a straight line graph here. Graph C, we have another curve, however this time it's not starting through the origin. That's an important thing to note here. It doesn't go through the origin. And these points of the graph tend to the y-axis and tend to the x-axis. They never reach them in this diagram. And then we have graph D. Similarly, the gradient of graph D is increasing, and we have a smooth curve here also. So now if I have a look at my types of proportionality, firstly here I have y is proportional to x. Now if y is proportional to x, this is a form of direct proportion. So they're in proportion. If one increases, the other increases proportionally. So if y is doubled, x is also doubled. So I could write this out slightly differently. I could take y being equal to some constant of proportionality, so k, some value k, multiplied by x is how I could write y is proportional to x. We don't need to know what k is, but I can see here that this form of the graph y is equal to something multiplied by x is going to be the form of a straight line graph. So similarly to y equals mx plus c. We don't have a c here because the y-intercept's 0. However, we do have this k, which kind of represents the gradient in this case. So this is going to give us y being directly proportional to x is this straight line graph. So graph B is going to be the correct answer for this one. And similarly here, for y is proportional to x squared, I can use the concept of this constant of proportionality again. So y is going to be equal to k lots of x squared, shows that y is proportional to x squared. Now, as for what this will look like on a graph, we have some value of k, so a constant, a rate constant, and we have y is equal to k lots of x squared. Now we've got this squared term, this squared value for x, so instantly here I'm realising that we're working with a quadratic. Now this is going to be a positive quadratic because k is going to be a positive constant in this case. X squared is always going to be positive, so it's always going to be increasing. So we can have a look at the graphs, and here I can see graph D. We have basically the part of a quadratic, a part of a simple quadratic, where we have y increasing at a faster rate than x. And that makes sense because if we're squaring x, and y is proportional to the square of x, y is going to be increasing faster than x, and we have this smooth curve here, so I can write down the answer of graph D for this one. And now here I would probably jump across to the last one in this column, just because it's probably easier to notice as we do see this graph come up quite a lot, and this is y is proportional to 1 over x. Now another way of saying this is that y is inversely proportional to x. So if one quantity increases, the other is going to be decreasing proportionally to this. So if y is doubled, x is going to be halved. So similarly here, I may already know the graph and I may realise that this is going to be graph C. This shows an inversely proportional relationship. However, if I didn't know that, I could have a look and I can see that the graph doesn't cross the x or y axis, it only tends to them. Now this makes sense because if x were to be 0, there are going to be no real solutions for a value of y, because 1 divided by 0 is going to give us a maths error. We can't calculate that value, so there's no solutions for y. So the other graph that we have left is graph A, and we have that when x is 0, y is also 0, and this definitely can't be the case because we cannot divide 1 by 0. So I can then fill in this as graph C, and then that leaves me with y is proportional to root x being graph A here, which we could see if we were to square both sides. So we had y squared is proportional to x. It's kind of the opposite of y is proportional to x squared, and this time we have a decreasing curve instead of this increasing curve that we had here, and that makes sense if we just look at the other graphs and work with the values that we're given. We could always substitute some values in if you weren't too sure on what would happen. Substitute some x and y values in and just get a rough idea of what happens with these graphs and to see the shape of the curve that it may create. So as for how the marks are awarded, we would get the first mark for getting 2 of the answers correct, and then the second mark would be for having all 4 of the answers correct here. And that brings us to the end of this question. So here we have a diagram, and we're told that A, B, C and D are all points on the circumference of a circle which has a centre at O, and we can see that in the diagram. So the centre here of O and the points A, B, C and D on the circumference of this circle. we're told that FDE is a tangent to the circle, so it meets the circle at one point, and that's going to be at this point D. And we're asked to show that y minus x is equal to 90 using this information and the diagram. And we're told that we must give a reason for each of our stages of working. So giving a reason for what we're doing in each stage is going to link back to the circle theorems and which circle theorems we've used in this question. So if initially I look at this diagram and look at what I'm trying to get the answer in the form of, we need y minus x is equal to 90. So somehow we're going to have to relate y and x to each other. However, I've noticed this value of 90 here, so maybe I should initially start by looking for a 90-degree angle in the diagram, which I could then go on to represent in terms of y and x. So looking for 90-degree angles and thinking back to my circle theorems, I'm instantly remembering one of the circle theorems, which is going to link the tangent of a circle and its radius. So this circle theorem is going to be that the tangent to a circle, so this circle that we have in the diagram, is going to be perpendicular. So at right angles to 90 degrees makes a 90-degree angle with to the radius of the circle. Now if I look in the diagram, we have the tangent here, and then the radius goes from the centre of the circle to a point on the circumference. So this line OD is the radius of the circle, and this meets the tangent here at point D. So the tangent is perpendicular to the radius, so we know that the angle ODE is going to be a right angle, and similarly the angle ODF is also going to be a right angle in this case. So therefore the angle ODE is equal to the angle ODF, and they're both 90 degrees. Now how can I use this to relate x and y together? So if we have the angle ODE, is there any way that we can kind of incorporate the angle x into this? For example, finding the angle BDE. Now we know that the angle BDE is going to be equal to x plus 90. So if there's a way that we can represent the angle BDE in terms of y, so if we can incorporate y into this somehow, then we're going to be finding an equation in terms of y and x. So we have the angle y over here, and instantly here I'm trying to look for another circle theorem. So I'm thinking about how I can relate this angle here to this angle here, and that's going to remind me of the alternate segment theorem. So the alternate segment theorem basically states that in a circle, the angle between a chord, so a point between 2 points on the circumference, so BD is a chord, AD is a chord, but we're working with BD in this sense, that the angle between a chord and a tangent through one of the endpoints of the chord, so D, the angle between this chord BD and the tangent FDE, so we could work with the angle BDE here, and that's going to be equal to the angle in the alternate segment. So if we're working with BDE, the angle in the alternate segment is going to be y here. This is the alternate segment. So now I can also say that angle BDE is equal to y, and that's due to the alternate segment theorem. Now we've stated our reasoning here, and if BDE is equal to y, and BDE is also equal to x plus 90, then x plus 90 is equal to y, and we can just rearrange that to give us y minus x is equal to 90 when we subtract x from both sides, and that is as required because that's what the question asked us to get the answer in the form of. Now as for how the marks are awarded here, you gain the first mark for finding one missing angle, so we found this 90-degree angle. There are lots of different ways you can go about doing this question, lots of different angles you can find and work with, but this is just the way that we've gone about doing it. A second mark is for a fully complete method leading to the correct final answer. There's lots of different ways again, so you could have taken different approaches and used different circle theorems, such as the fact that the angle at the centre is twice the angle at the circumference, and then the opposite angles in a cyclic quadrilateral sum to 180. A couple of different ways there to go about doing it, but this third mark is for giving reasoning for all of your methods. So for stating both of these circle theorems, that gains us the third mark, but you could have gone about it using different circle theorems in this question. So we're now told that Dylan was asked to give some possible values for x and y. He said that y could be 200 and x could be 110 because 200 minus 110 is equal to 90, so y minus x equals 90, which is what we saw in the previous part of the question. And we're asked whether Dylan is correct, giving a reason for the answer that we decide on. Now if I'm to refer back to the diagram in this case, I need to look for a reason as to why or why not this could be possible. Initially here I'm looking at the angle for y being 200 and thinking that this is quite a large angle. So angle y in the diagram is part of a triangle, and angles in a triangle are going to sum to 180. But this angle of y is 200 is one of the values that Dylan has given here. Now we know that this can't be possible because if angles in a triangle sum to 180, y has got to be less than 180 because it's in a triangle, so it can't be 200 in this sense. And that is going to be sufficient reasoning to gain us the mark here. So I'm going to state my answer as no, y must be less than this value of 180 as it is an angle which is in a triangle, and angles in a triangle sum to 180, and that will gain us the mark here. So here we have a distance time graph which shows information about part of a car journey. So on the y-axis here we have the distance travelled by this car, and then on the x-axis we have the time in seconds. And we're asked to use this graph to estimate the speed of the car at the time 5 seconds. So if we have the distance on the y-axis and this time on the x-axis, I can already see this relationship between distance and time and how it might give me speed. Now if I have a look at the equation, speed is going to be equal to distance over time. And now we have distance and time, distance on the y-axis, time on the x-axis. And if I have a look at what the gradient of a graph is, so m, that's going to be equal to the change in y divided by the change in x. Now in this case, the y-axis has distance on, so distance and the change in y, over the change in the x-axis, which is time. So in order to get the speed at a certain given time, the instantaneous speed, I need to find the gradient of the graph at this point. And in order to do this, I can use drawing a tangent and then find the gradient of this tangent. So if I need to find an estimate for the speed of the car at 5 seconds, I can go to 5 seconds on the x-axis and then trace upwards until I meet the graph at this point here. So then at this point here, I now need to draw in a tangent. So a tangent is a line that's going to be at 90 degrees to this point of the curve. So if I sketch in a line here that touches this point on the curve at 90 degrees, I've now drawn in a tangent. And in order to find the speed of the car at this time, I need to find the gradient of this tangent. So I need to find the change in y over the change in x. So I can take values, for example, if I go from this point here and draw a triangle downwards to the bottom of my point here. So this is going to be the change in y, and then this value here is the change in x. So the gradient is going to be equal to the speed, which is the change in y. So we've gone from this value of 68 here for the change in y, down to a value here of 4. So 68 minus 4 is the change in y, and that's going to be over the change in x, which we have here is at this point 7.8, and then we're subtracting this value here, so 3.2. So I have 64 divided by 7.8 minus 3.2. So that gives me 4.6, and I have 64 divided by 4.6, and that gives me an answer of 13.9. So the final answer here of 13.9 meters per second is going to gain me all of the marks for this question. The first mark would be for drawing the tangent to the curve at the point where times 5. And then there's going to be another mark for the process of finding a gradient of this tangent. And then the final mark is for an answer in the range of 11 to 19 meters per second, just depending on how exactly the tangent's been drawn in, as this may cause a slight difference in the gradient. So here we're told that a darts team is going to play a match on Saturday and on Sunday, and we're told that the probability that the team will win on Saturday is 0.45. We're then told if they win on Saturday, then the probability that they will win on Sunday is 0.67. And then if they do not win on Saturday, then the probability that they will win on Sunday is 0.35. And we're asked to use this information to complete the probability tree diagram that we have below. So I'm just going to start by making sense of this diagram. So here we have Saturday, so this part of the tree diagram is representing Saturday, and the two options are they'll either win or not win. And these are the exhaustive set of outcomes. They will either win or not win. There's not a third option, so the probabilities of these are going to have to sum to 1, because it's certain that they will either win or not win. We then have the same for Sunday, however, this branch of the tree diagram is dependent on them winning on Saturday, and then this one here is dependent on them not winning on Saturday. So if we have a look, firstly, we need to fill in all of the gaps, and we can start here with the probability that they won't win on Saturday. Because we know that the probabilities here must sum to 1, we can simply do 1 minus 0.45, and that gets an answer of 0.55. So these probabilities of winning and not winning on Saturday now sum to 1. Now I need to look back in the question at the information, and we're told that if they win on Saturday, so they win on Saturday, so we're looking at this branch of the tree diagram now, the probability that they will win again on Sunday, so on Sunday that they will win having won on Saturday, is 0.67. So I can fill that in this box here. And then similarly again, the probability of them either winning or not winning after having won on Saturday, these two probabilities in this section have to sum to 1 again, because those are the only two outcomes that can happen on Sunday. So 1 minus 0.67 is going to give us an answer here of 0.33. And then finally we can fill in the last gaps. So if they do not win on Saturday, so they don't win, so we're looking at this part of the tree diagram, then the probability that they will win on Sunday is 0.35. So the probability that they will not win is 1 minus 0.35. So that gives us an answer of 0.65. Now we would gain the first mark here for getting this probability of 0.55 in the correct place, and then the second mark is going to be for a fully correct labelled tree diagram. So here I'm asked to find the probability that the team will win exactly one of the two matches. So if I have a look at the tree diagram, there are two ways of this happening. So they have to win exactly one, so they could either win on Saturday and then lose, not win on Sunday, and they've won one match. Or alternatively, if they didn't win on Saturday, they could then go on to win on Sunday and win exactly one match in total. So now I need to find the probability of these two events occurring, and then I can add them together to find the total probability that they'll win exactly one match. So if I want to work out the probability that they win on Saturday and don't win on Sunday, we're working horizontally across the tree diagram. And when we're working like that, we're going to multiply the probabilities together. So here, if we have the probability that they win on Saturday, which is 0.45, we can multiply that by the probability that they don't win on Sunday, so 0.33, to get the probability of them winning on Saturday and not winning on Sunday. And that gives me an answer of 0.1485. And then similarly, I can do the same below. So when they don't win on Saturday, 0.55, and we'll multiply that by the probability that they do win on Sunday, so 0.35, and that's going to give me an answer of 0.1925. Now, in order to find the probability, the total probability for them winning exactly one match, we're now working downwards down the tree diagram again in a way, so we can simply add these two probabilities together to find this total probability. And that gives us an answer of 0.341. And that is going to be the correct final answer for this question. Now, as for how the marks are awarded, we'd have gained our first mark for firstly finding one of these values, so doing this multiplication here. And then a second mark would be for following through with the method and basically adding together the two probabilities. And then the final mark is for the correct final answer that we have here. So we're asked to draw on the grid the graph of x squared plus y squared is going to be equal to 12.25. Now instantly here I can see that we've got a squared x term and a squared y term, and this makes me think that we're working with a circle. So we have x squared plus y squared plus is equal to a number, and this is going to be kind of the simplest form of a circle graph. So we're going to have a centre of this circle at the point 0, 0, because we don't have any sort of a or b values, so x plus a or y plus b, we don't have these values, the centre is just going to be at 0, 0. And then we just need to know the radius of the circle to draw this on the graph, and the radius of the circle is going to be this number that we have here, but the square root of it. So the radius is going to be equal to the square root of 12.25, and that gives us an answer here of a radius of 3.5 and this centre of 0, 0. Now I can plot a couple of points just to see exactly where my circle is going to go. So if we have a centre of 0, 0, we can simply go up 3.5, and we can go along the axes 3.5 in every direction. Just plot a few points in these places, and then we can just draw in the circle in order to draw this graph. So we'd get the first mark for either having the correct centre or the correct radius, and then the second mark is going to be for the fully correct final answer here. So now in part B, I'm asked to hence find estimates for the solutions of the simultaneous equations. And then we have the x squared plus y squared is equal to 12.25, so this circle that we drew in the graph previously. And we also have 2x plus y is equal to 1 as a second equation here. Now the word hence in the question means that we could rely on the knowledge in the previous part of the question in order to find the answer here. So one way of doing this would be to draw the line of 2x plus y equals 1 onto the graph and find the points where this line and the circle intersect, and the x and y values at these points are going to be the solutions. A slightly different way I could go about this is by starting by eliminating a variable. So eliminating one of the variables and doing this in a more algebraic way. So if I take the second equation that we're given here, 2x plus y equals 1, if I want to get this in the form of either x plus y is equal, or x or y is equal to something, I could subtract 2x from each side, leaving me with y is equal to 1 minus 2x. Now looking back to the first equation, I can now get this just in terms of x, because I have x squared plus y squared, and we know that y is equal to 1 minus 2x, so we can square that, and that's going to be equal to 12.25. I can multiply out the brackets, so we have x squared plus 1 minus 2x plus 4x squared is equal to 12.25. And now I can simply collect like terms and rearrange this to get in a form that I'm going to be able to solve as a quadratic equation. So we have 5x squared minus 4x minus 11.25 is equal to 0. Now this isn't going to factorise easily, so here I'm going to be using the quadratic equation. So if I have a is equal to 5, b is equal to minus 4, and c is equal to minus 11.25, then we have x is going to be equal to minus b, so minus 4 gives us positive 4, plus or minus the square root of b squared, so minus 4 squared, minus 4 lots of a, which is 5, times c, so minus 11.25, and that's all going to be over 2 lots of a, so 2 lots of 5. And that's going to simplify to an answer of 4 plus or minus the square root of 241 all over 10. So these are going to give me the two possible x solutions here. So if I evaluate this, I'm going to have x is either equal to 2.0 to 1 decimal place, or x is equal to minus 1.2 here. Now in order to find the corresponding y values, I can go back to this rearrangement that I had here. So to find the y value corresponding to each x value, I take 1 and then I subtract 2 lots of the x value, making sure to use this form of the x value, not the rounded form, to ensure that my answer is going to be accurate. So if I substitute this into the formula, so 1 minus 2 lots of 4 plus root 241 over 10, etc. If I do this for both of them, I get answers of y being equal to minus 2.9 when x is 2.0, and then y being equal to 3.3 here. Now, making sure we pair these up correctly is going to be important, because the matching of these gets us a mark here, and so does having the correct pair of x values or the correct pair of y values, or one of the correct pairs from the two, that would gain us a mark. And then the first mark in this question was simply for either drawing the line on the graph or correctly eliminating one of the variables like we did here. So in this question here, we have a histogram which shows information about the times taken by some students to finish a puzzle. So then we have the histogram, and on the y-axis, as we'd expect, we have the frequency density, and on the x-axis, we're using a measure of time taken in minutes here. We're asked to use this to complete the frequency table for this information, and if I look at the frequency table, in this column we've got the time taken in minutes, so these intervals, which are going to correspond to each bar, and then we're going to have in the second column, which we need to fill in, the frequency for these bars, for these intervals. So if I have a look at the first one, so we have 0 to 5, that's going to correspond to this bar here, 0 to 5. This is also known as the class width, so the x-axis is going to be taken as the class width, and the class width of this bar is 5 minus 0, so it's got a width of 5. Now in order to calculate the frequency, I'm going to use the formula. So the frequency is going to be equal to the frequency density, so in this case what's on the y-axis, multiplied by the class width, so the CW, which is basically the x-axis here. So we're measuring the class width for the time taken. So if I'm going to use this kind of formula to work out the frequencies for each interval, we can firstly look at this one, so 5 to 15. That corresponds to this bar here, and it has a class width of 15 minus 5, so 10, and it's going to have a height or a frequency density of 0.4. So here we're going to have 10 multiplied by 0.4, and that gives us an answer here of 4. Similarly, for the second bar, for the next one along, we've got the class width 15 to 25 here. This bar, which is a class width of 10, it's got a height of 0.6, so a frequency density of 0.6. So we're going to have 10 multiplied by 0.6, and that gives us an answer of 6. And then we can just apply the same principle to the last two. So this one has a class width of 5 this time, 25 to 30, and a height of 1. So 5 multiplied by 1 gives us an answer of 5. And then finally we have a class width from 30 to 50, which is 20. The difference is 20. And the height is 0.2. So 20 multiplied by 0.2 gives us an answer of 4 here. So as for how the marks are awarded, you would get the first mark for getting 2 of the answers, the frequencies, correct, for finding 2 of these, and then the second mark is for a fully correct final answer of all 4 frequencies calculated from the histogram. We're now asked to find an estimate for the lower quartile of the times taken to finish the puzzle. And we can obviously use this data that we've just put together, and we're going to use the frequencies. So we've basically put together for ourselves a frequency table here. So we have the frequencies for each set of times. So in order to find the lower quartile, which is quartile 1, we need to find the n plus 1 over 4th piece of data and then see what time that's going to correspond to. And n here is going to be basically the cumulative frequency, so the total number. If we add together all of the frequencies, this total is going to be n. So in this case, this is the total number of people that took part in finishing the puzzle. So if we add all of the frequencies together, so 4 plus 4 plus 6 plus 5 plus 4, we get to an answer of 23. So in order to find the lower quartile, I'm going to take 23, add 1 and divide that by 4. So that's 24 divided by 4, and that means I want the 6th piece of data. Now in order to do this, I'm going to have to interpolate. So I can see that in the 0 to 5 range here, there are 4 pieces of data. However, we want the 6th piece, so we want 2 more than this piece of data. So we're going to have to break into the next row of the table here. And we've already used up 4, and we want the 6th piece, so we're going to go 2 further into this lot of 4. And here, 2 over 4 is basically the same as a half. So we want halfway into this interval that we have here. So we're going to go halfway through here because the 6th data set, 6th value is going to be halfway into this frequency of 4 for this specific bar. So we're going to go halfway between 5 and 15. So we can just do this by doing 15 minus 5 divided by 2 gives us 10 over 2, so 5. And we're going to add that on to the first value in the interval. So 5 plus 5 gives us an answer of 10. And that's going to be the correct number of minutes here. The answer of 10 is going to give us the correct final answer to gain us the mark here. We would have gained the first mark for this calculation that we used here to find the value that's representing the lower quartile, and then the second mark for the final correct answer of 10 here. So in this question, I'm given this cuboid, which I can see in the diagram, and I'm told some information about it. So I'm told here that the length AB is going to be 7.3 centimetres. So I can label that up to begin with. Here, 7.3 centimetres. And because I'm working with a cuboid, I also know that the length DC, EH and FG are all going to be equal to AB. They're all going to be 7.3 centimetres. Similarly, for CH being 8.1 centimetres, I'm going to label that up. And I also know that ED, FA and GB back here are all 8.1 centimetres also. So it's really important to label up the diagram before we get started with the question, just so we can see exactly what we're working with and visualise these numbers a bit more clearly. I'm then told that angle BCA is equal to 48 degrees. Now if I have a look, the angle BCA is this angle in here, and I can draw that in. If I draw the line AC in, this angle here is angle BCA, and that's 48 degrees. I'm then asked to find the size of the angle between AH and the plane ABCD, so this rectangular face at the bottom, and I'm asked to give my answer correct to 1 decimal place at the end here. So I'm also just going to draw in the angle that I'm trying to find, just so that I can see how I might plan a strategy to go about finding it. So if I draw in the line AH, and the angle that I want to find is between the line AH and this line here, AC, which is basically the plane here. So I need to find this angle and give it to 1 decimal place. Now also here, I've noticed that because I'm working with a cuboid, the angles in the corners, so this angle here, etc., are all going to be right angles. They're going to be 90-degree angles. And that comes in really useful when making a right-angled triangle, because if this angle here is a 90-degree right angle, that means that the triangle ABC is going to be a right-angled triangle. So if I draw the triangle ABC out again, just to make it a bit easier to work with, we have the right angle obviously, and then we have the angle BCA, which is 48 degrees. We also have the side length AB, which is 7.3 centimetres. Now in order to find the angle what we're looking for, we can use this triangle to work with it in order to find this angle here. So if we were to know the length of AC, this angle here between the plane and the line CH, that's also going to be a right angle because we're working with a cuboid. So we'll then have another right angled triangle of which we'll know this side length and this side length, AC, so we'll be able to calculate this angle using trigonometry. So this basically means that I'm looking to find the length of the side AC. So in order to calculate AC, I'm going to have to use trigonometry on the triangle ABC. So if we're working with, if I draw this out again, this angle is 48 degrees, and this side 7.3. We basically need to find AC, which relative to the angle is the hypotenuse, and then this side's the opposite. So we're working with the opposite and hypotenuse, so we're working with sine. So sine of the angle, so sine of 48, is equal to the opposite, which is 7.3, over the hypotenuse, which is this length AC. So AC is going to be equal to 7.3 divided by sine of 48, and that gives us an answer of 9.8231, just to 4 decimal places there. Now that I've got the length AC, I can now use it to work out this angle that we're looking to calculate. So I can draw out the other triangle that we're working with, the triangle AHC, we're looking to calculate this angle here. We know that CH is 8.1 centimetres, and we now know that AC is 9.8231, but we'd use the exact value in our calculators there. So now, relative to this angle, we have the opposite side and the adjacent. So O and A, we're working with tan. So tan of theta is equal to the opposite over the adjacent. So the 8.1 divided by 9.8231, the exact value there. So theta is going to be equal to the inverse tan of this value. And if we put that into our calculators, it gives us an answer here of 39.508. And we've been asked to give this answer to 1 decimal place. So to gain the final mark here, I'm going to give my final answer of 39.5. Now, as for how each of the marks are awarded here, we would gain the first mark for starting a process to try and work out one of these sides or angles. So for this line of working here, that would gain us a mark. The second mark would be for a complete correct process to find the length AC, which we've done here in this second line. The next mark would be for using tan to find the angle that we're looking for. So for basically writing this line here, and then the final mark is going to be for this correct answer of 39.5 given to this 1 decimal place using the inverse of tan here. And that brings us to the end of this question, for which there are 4 marks available, so it is important to draw the diagrams and show your working throughout the question. So here I have shape S, which is 1/4 of a solid sphere which has a centre at the point O, which we can see on the sphere here. Over here we're given the formulae for the volume of the sphere and the surface area of a sphere, which we're going to need both of these. They're both going to come in useful for this question. We're then told that the volume of S is 576 pi centimetres cubed, and we're asked to find the surface area of S, given our answer correct to 3 significant figures. So initially here, we're given the volume of S, and S is going to be 1/4 of a sphere. Now, if we want to work out the surface area, if we look at the formula for the surface area, 4 pi is a constant, so we need to work out the radius of this sphere. And we know that the radius is the distance from the centre to a point on the outside of the sphere, on the surface. So this distance here is going to be r. And we need to find r with the information that we're given in order to work out the surface area. So if we have the volume of S to be 576 pi, that is 1/4 of a sphere. So if we were to multiply the volume of S by 4, we're now going to have the volume of what the sphere would be if it was a complete sphere. And it's going to have the same radius that this sphere has, it's just going to be the complete sphere, not 1/4, not a segment of it. So now we can use the formula up here for the volume of a sphere, and we can put this next to this because we know that 4 lots of the volume of what we have, the volume of S, is going to be the volume of a whole sphere. So that's going to be 4/3 pi r cubed. Now we can work with this, we can just kind of simplify it down and find out what r is in this instance, so we can work out the surface area. So we have that 2,304 pi is equal to 4/3 pi r cubed, but we can divide both sides by pi, so the pi's basically cancel out in this case. So that leaves us with 2,304 equal to 4/3 r cubed. So r cubed is going to be equal to 3 times 2,304 all over 4. And if we cube root that value, we're going to be left with the cubed root of 1728, and that gives us a value for r, the radius of this shape, to be 12, and the units are going to be centimetres here, although that's not too important in this instance. So now we know that the radius of this shape is 12, and we can use this to go back in and find the surface area. So if I have a look at the formula for the surface area, we know that that's 4 pi r squared, and that's the outer surface area of a sphere, so the curved side, so kind of this side in here. Now we have a shape S is a quarter of the sphere, so we only need a quarter of the surface area to get this curved side, the surface area of the curved side. So if we do a quarter times 4 pi r squared, that just leaves us with pi r squared, and that's going to be the surface area for this curved side. But we now also need these two sides here that we have. And as you can see, this line goes through the centre, this is the diameter, and we have half of a circle here. This is half of a circle with radius r, which we've calculated to be 12. And this side here is also half of the circle with radius r. And the formula for the area of a circle is pi r squared. So we can work with this. So we only have half of the circle here, so we can divide that by 2 to find the area of this face. But then we have another face that's going to be exactly the same area, half of the circle with radius r, so we multiply that by 2, and that just gives us pi r squared as well. So now we can add these two surface areas together. Pi r squared plus pi r squared gives us 2 pi r squared, and that's going to be the surface area of S. And we can just substitute the numbers in, so that gives us 2 times pi times the r, which is 12 squared, which gives us an answer of 288 pi. And it's asked us to give our answer to 3 significant figures, so we need to work out what this is as a numerical value, not in terms of pi, and that gives us an answer of 904.779, and rounded to 3 significant figures, that gives us a final answer of 905. This was quite a big mark question, so it was useful to go through the steps logically and work out what we were planning on doing with this question before we started with it. So as for how the marks are awarded, you'd gain a first mark for using the correct formula for the volume of the sphere here, so multiplying that by 4, making it equal to one another. A second mark for correctly finding r to be 12, or for saying that r is the cubed root of this value that we had here. The next mark is for a process to find the curved surface area, so a quarter of the surface area. And then another mark for finding the complete surface area, so doing this kind of sum to get 2 pi r squared. And then for subbing in the values and getting the correct final answer to 3 significant figures, we gain this final mark here for the answer of 905 centimetres squared. So here we're told that Martin did this question. He was asked to rationalise the denominator of this fraction that we have here. So we can see we have this surd, this root 3 in the denominator, so we need to basically get rid of that somehow. We're shown how he answered the question and told that his answer is wrong and asked to find his mistake. So when we're working with rationalising a denominator like this, we're going to start by multiplying through by, instead of having a positive sign here, we take the denominator and make this negative. So we're going to multiply through by 2 minus root 3 over 2 minus root 3. So this is just the same as multiplying by 1, but this is going to take the surd out of the denominator because the minus 2 root 3 and positive 2 root 3 are going to cancel out when we expand the brackets. So as you can see here, he's multiplied through by 2 minus root 3 on the top and bottom, which is correct. When he's done this, he has then gone on to expand it out. So we have the 14 multiplied by the 2 to give us 28, and the 14 multiplied by minus root 3, which gives us minus 14 root 3. So the numerator here is correct. And then for the denominator here, well, he started by taking the 2's, multiplying those out using this method. So he's taken the 2's and that's given the 4, which is correct here. He's then done the 2 multiplied by the 2 multiplied by the positive root 3 here, so these two, to give us this part. Then the 2 multiplied by the minus root 3 to give us minus 2 root 3. And then finally, he's got root 3 multiplied by minus root 3. Now, if we were to take this and simplify it into one third, this is going to leave us with an answer of minus root 9. And the root of 9 is 3, so we have an answer of minus 3. However, here, he has got this plus 3 on the end here, so this is where he has made the mistake. So in order to gain the mark here, I simply need to write out that root 3 times minus root 3 is equal to minus 3, not 3, that he has written here. So similarly here, we're told that Sian did this question. She was asked to rationalise the denominator of 5 over root 12 this time. We're shown how she answered it, told that she was wrong in the answer, and we're asked to find her mistake again. So this time she's taken 5 over root 12, and then she has multiplied through by root 12 over root 12, which is the correct thing to do here because it's going to take the root 12 out of the denominator. So she's multiplied by root 12 here and root 12 here, and that's going to be correct. Then she's taken the denominator, root 12 squared basically leaves us with 12, so that's correct here. However, when she's gone to simplify 5 root 12, she's gotten that to an answer of 5 times 3 root 2. However, when we look at root 12, if we want to simplify that down, we can write that as a product of two surds, and one of them being a square number. So the factors of 12, 4 and 3 here will work. The square root of 4 is going to be an integer value of 2. Root 3 can't be simplified any further, so that leaves us with 2 root 3. So root 12 actually simplifies to 2 root 3, not this value of 3 root 2 that she's got here. So to get the mark here, I'm simply going to write out that root 12 is equal to 2 root 3, not 3 root 2, and that will gain me the mark for this question. So in this question, we're told that Jackson is trying to find the density in grams per centimetre cubed of a block of wood. The block of wood is in the shape of a cuboid. And we're told that he measures the length as 13.2 centimetres, and that's correct to the nearest millimetre. Measures the width as 16 centimetres, correct to the nearest millimetre, and then the height as 21.7 centimetres, correct to the nearest millimetre. He then measures the mass as 1,970 grams, correct to the nearest 5 grams. And we're asked to, by considering bounds, work out the density of the wood, given our answer to a suitable degree of accuracy. And we're told that we must show our working and give a reason for the final answer that we come to. Now, instantly here, when we're looking at the phrases correct to the nearest, I'm instantly thinking that we're going to be working with bounds, and we're going to be working with an upper and lower bound for density in the end, using upper and lower bounds of mass and volume. Now, if I have a look, the units for density are grams per centimetre cubed, and that is mass divided by volume. And here we can see we have the units of centimetres, which we're going to cube basically, and then the units of grams, so we don't need to do any unit conversions here. It's always a good idea just to check through and see if we're going to have to convert any units, just in case. So we know that density is going to be mass divided by volume, and we're going to be looking to find an upper and lower bound for density in order to come to some kind of conclusion as to what we can work with. So an upper bound for density. We want the highest value of density possible, and that's going to occur when the numerator, so the mass, is the highest value possible, so the upper bound for mass, and then the lower bound for volume. That's going to give us the highest value for density, so the upper bound, and the lower bound for density is going to be the opposite. So we want the lower bound for mass, so a smaller numerator, and having that over a larger denominator is going to give us the lower bound here. So in order to calculate these, we're going to need to work out the upper and lower bounds of the volume and the mass. So if we start here with the mass, as it's just easier to work with, he measures 1,970 grams correct to the nearest 5 grams. So we basically need to divide this 5 by 2 to get 2.5, and then we can go 2.5 above and below this value of 1,970 to get the bounds. So the upper bound of mass is 1,970 plus 2.5, so 1972.5, and then the lower bound is it subtract 2.5, so 1967.5. We can now go on to work out the volume, the bounds for volume, and the way that's easy to work with this, we know that the volume is going to be the length times the width times the height. So an upper bound for volume is going to be the upper bound for length times the upper bound for width times the upper bound for height, because we're simply multiplying these values together, so we want to get the highest possible values of each to get a higher value in the end. So we can have a look at these and we can work out the bounds for the length, width and height. I'm going to put this into a sort of table just to make it easier to see and work with. So to start we have the length of 13.2, a width of 16.0 and a height of 21.7, and I can then make a column for the upper bound and the lower bound for each measurement. They're all measured to the correct nearest millimetre, so we can basically go 0.5 millimetre above and below for the bounds here. So 0.5 millimetre above 13.2 gives us an answer of 13.25, and then below is 13.15. And then similarly here we can go 16.05, 15.95, 21.75 and then 21.65. Now we have the upper and lower bounds for the length, width and height. We can calculate the bounds for the volume. So the upper bound for volume is the upper bounds for length, width and height multiplied together. So 13.25 times 16.05 times 21.75. And that gives us an answer of 4,625.4, just to one decimal place. Similarly, for the lower bound for volume, if we do the same thing, we get an answer of 4,540.9. Now we have the bounds for volume and mass, we can go back in and calculate the bounds for density. So the upper bound for density we worked out to be the upper bound for mass over the lower bound for volume. So we take the upper bound for mass, which we had as 1,972.5, over the lower bound for volume, which is 4,940.9, but we'll use that to all of the decimal places that we've kept in our calculator. And that is going to give us an answer of 0.4344. And then the lower bound for density we have as the lower bound for mass over the upper bound for volume. We take those values and that gives us an answer of 0.4254. Now, as we can see, the lower and upper bound for density are very similar. In fact, they're the same when they're rounded to two decimal places or 2 significant figures. So the question is asking us to give our answer to a suitable degree of accuracy for the density of wood. So taking these bounds into account, I'm going to give my answer as 0.43. And I can do this because both the upper and the lower bounds in this instance for the density round to the value 0.43 to 2 decimal places or 2 significant figures. So that's the justification at the end. We're saying that this is accurate because the upper bound and lower bound that we've calculated are going to round to 0.43 to 2 decimal places, so it wouldn't be appropriate to round to any more decimal places in this instance. As for how the marks are awarded here, we'd gain a mark for working out one of the bounds. So, for example, for the upper bound for maths, we'd gain a mark here. We'd gain a second mark for finding the bounds for volume that we've calculated here. We would then gain a third mark for a correct process to find the bounds for density. So for using this sort of formula here and the right general idea. Would then gain another mark for both of the correct bounds for density to 3 significant figures at least. And then the final mark is for this conclusion here and the final answer of 0.43.